Hi everyone. Question number 6 of the exam style questions asks us to list all the prime numbers from 0 to 40. So in here I have expressed the the answer in a way that all the steps get clear to you. How do we find the prime numbers from 0 to 40? So what I have done is that I have mentioned all the numbers from 0 to 40, and in front of every number I have mentioned if it's prime or not prime, and if it's prime, what's the reason, and if it's not prime, what is the reason. So taking a start, we define prime numbers as those numbers who are having only two factors, and those two factors are 1 and the number itself. So taking a start from 0 as it's asked in the question, so 0 we categorize it to be not prime. Why? Because it has many factors. How? 2 multiplied by 0 is equal to 0. 10 multiplied by 0 is equal to 0. 100 multiplied by 0 is equal to 0. So it has infinitely many factors, therefore we cannot categorize it as prime number. 1, on the other hand, is also not a prime number because as per the definition of the prime number, it shall have two factors, 1 and itself, but in here it has only one factor, which is 1 itself. So therefore, 1 is not prime. 2, on the other hand, it has only two factors. 2 is the only even prime number. So 1 and 2 are the factors of 2 number or integer. 3 is also a prime number because it has only two factors, 1 and 3. 4 is not a prime number because apart from 1 and 4, we have 2 multiplied by 2 is equal to 4 as well, so it's not a prime number. 5 is a prime number because other than 1 and 5, there are no other factors of 5. Not prime, 6 is not a prime because 2 multiplied by 3 is equal to 6 as well. So apart from 1 and 6, we have other factor pairs as well. 7 is a prime because it comes in the table of 1 and 7 only, or it's completely divisible by 1 and 7 only. There are no other factors that can evenly divide this number. 8, 2 multiplied by 4 is equal to 8, so it's not a prime because it has more than two factors. 9, we cannot say that it has more than two factors, but it's like apart from 1 and 8, it has other factors as well. 9 is not a prime because it has many other factors other than 1 and 9. For example, 3 multiplied by 3 is equal to 9. 10, 2 multiplied by 5 is equal to 10. So 9 and 10 are also not prime numbers because it has many factors. 11 is a prime number because it has 1 and 11 as factors. It has only two factors. That's it. No other factors other than 1 and 11. 12 is not a prime because it has many factors. For example, 2 multiplied by 6 is equal to 12. 13, on the other hand, is a prime number because it has only two factors, 1 and 13. 14 is not a prime number. For example, we have factors like 2 multiplied by 7 is equal to 14. So it has many factors and it's a composite number. 15 is also not a prime number. It's a composite number because 3 multiplied by 5 is equal to 15. So it has many factors. 16 as well, 2 multiplied by 8 is equal to 16. So not prime but a composite. 17, it is a prime because it has only two factors, 1 and 17. 18, it is not prime, so 2 9s are 18. It is a composite number. 19 is a prime number because it has only two factors, 1 and 19. 20 is not prime. 2 multiplied by 10 is equal to 20. Has many factors. 21 is not prime. For example, 3 multiplied by 7 is equal to 21. Has many factors. 22 is not a prime number. 2 multiplied by 11 is equal to 22. 23 is a prime number. It has only two factors, 1 and 23. 24 is not a prime number. 25 is not a prime number, 26, 27, 28, and in here, other than 1 and the number itself, some other factor pairs I have given in here for you to see that they're having many factors. For example, 2 multiplied by 12 is equal to 24, 5 multiplied by 5 is equal to 25, 2 multiplied by 13 is equal to 26, 3 multiplied by 9 is equal to 27, and 2 multiplied by 14 is equal to 28. 30 is also not a prime number. 3 multiplied by 10 is equal to 30. So many factors. We can say 31 is, on the other hand, is a prime number. It has factors of 1 and 31 only. 32, not a prime. 2 multiplied by 16 is equal to 32. 33, not a prime. 11 multiplied by 3 is equal to 33. 34, not a prime. 2 multiplied by 17 is equal to 34. 35, not a prime. 5 multiplied by 7 is equal to 35. So you see all those numbers that are not prime, it has more than 2 factors, and they are composite numbers. 36, it's not a prime. For example, 2 multiplied by 18 is equal to 36. 37, on the other hand, is a prime number because it has only 2 factors, 1 and 37. 38 is not a prime number because it has factors like 2 and 19. 2 multiplied by 19 is equal to 38. 39 is not a prime number because it has factors like 3 multiplied by 13 is equal to 39. 40 is not a prime number because 2 multiplied by 20 is a factor pair, and indicating that it has many factors based on which we categorize it to be a composite number rather than a prime number. So now from 0 to 40 we have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31 and 37 to be the prime numbers. And we have not only shown that or expressed or enlisted the prime numbers, but also we have mentioned as to why do we categorize them, or how, based on what conditions we categorize them to be prime, and what condition we categorize them to be not prime or composite numbers. That's all for this question. Happy learning!